This is 11.4b of geometry. So we're going to start out by finding the volume of cylinders. So again, we can just use our generic equation that we've been using so far. V equals BH, where B is the area of the base, and then H is the height. Or we can specify it a little bit more for cylinders because the area of the base of a cylinder is always going to be pi r squared because it's a circle. So V equals pi r squared H is the specific equation for the cylinder. So let's use it. We're going to use an oblique cylinder here, which means that it's not right. It's not going straight up and down. The only thing that's different is that on a regular one, our height is just the side length, kind of what you would call the side. And this is our height right here. It needs to be perpendicular to the base. So volume is equal to pi r squared H, or V equals base times height. I'm going to use this one. The generic one you just plug in, right? I want to make sure you know how to use the generic one. So the base is pi r squared, right, because it's a circle. And again, the advantage for using this equation is that you only have to memorize one. You already have all those area equations memorized. So you can just use the generic volume and plug in. So our diameter is 2, which means that our radius is 1. So B is equal to pi 1 squared, which is just pi times 1, which is pi. So up here, pi is my base. My height is 3. So I get 3 pi. But here's the deal, I need units. So 3 pi meters cubed because we're doing volume. And that would be my answer. So a composite space figure is a three-dimensional figure that is the combination of two or more simpler figures. So basically we're sticking two 3D figures together to make one shape. So they found the area of this tank. We're going to find, volume. We're going to find the volume of this lunchbox. So you can see that it's split into two pieces, right? The top part is half a cylinder, and that bottom part is a rectangular prism. So why don't we start with a rectangular prism? I think that's the easier one. So volume is equal to base times height. So the area of our base, it's 10 by 6, so 10 times 6, which is 60 inches squared. So I can plug that up here, times our height is 6, so that gives us 360 inches cubed. And then up top, I'm going to first just find the volume of this cylinder, and then once I get to the very end, then I'll take half of it. Okay, so V is equal to BH, where our base is pi r squared. So they mark our radius here, that's 3. So pi 3 squared. 3 squared is 9, so this is 9 pi inches squared. And then if we plug it into the volume equation, 9 pi times our height. So if you maybe you have to turn your head to picture the cylinder, but this right here is our height. And that matches up with this down here. So our height here is 10 inches. So 9 pi here, right, times 10, our height, which gives us 90 pi inches cubed. That's for our whole cylinder. So if we take half of that, we get 45 pi inches cubed. And then we need to add those two. So 360 plus 45 pi. Now is where I'm going to change that pi stuff into a decimal. So 45 times pi gives us about 141. So 360 plus 141 gives us 501 inches cubed. So that lunchbox has a volume of 501 inches cubed. So make sure you split it up into two pieces that you know, okay? There's not always one exact way to do it. Sometimes there's multiple ways you can do it too. And there's your homework.